Today we're going to key out kind of a fun plant for early spring in a common family. I've gone ahead and the plant we're going to key today, I've pulled all the way from the roots all the way up to the flowers and fruits. I want to focus on a couple things. When you first start grabbing a plant to key, it can be really helpful to make sure you grab it all the way from the base. This plant, you'll notice it has very clear opposite leaves right at the base. And then as we travel up the stem, the leaves become alternate. A deep dive into our flower here lets us look really closely, and you can see that the flowers are coming off one at a time from the stem, so that's a typical raceme inflorescence. And we can take a little bit more of a deep dive into the flower itself. You see that it has 4 petals right away. We haven't counted the stamens. Look closely and we see that we actually have some really nice little sepals here too. Look closely at this flower. Once we've taken it apart, you can see that we actually have 4 pretty clear sepals. One thing that you'll notice, you can see a little bit more on the developing flowers here, is that the sepals seem to have a little kind of sac at their base, and then the petals come off almost like they've got a claw on them. They come off individually, and so these petals easily separate. They are not conadenate to each other. They're not connate. Okay, so they're separate. The sepals come off separately too. See, I accidentally just right there pulled off a stamen along with sepals. Stamens easily separate. Petals easily separate. Okay, so far I'm up to over 4 stamens. I've got one little sticky there. I've got 1, 2, 3, 4, 5, and if I keep looking there, I should actually have a 6th. Notice how some of these are kind of short and some of them are taller than others. 2, 3, 4. There's my 5th. I've got a 6th one. And then if we look really close, you can see my stigma. I'm showing my ovary here, and the ovary is actually up on, it's kind of like it's up on a little stalk. So I've got a receptacle where all the flower parts were, and then my ovary is there. Inside my more intact flower, like this individual here, we should be able to actually count our stamens a little bit better, since we may have lost one there. So let's take a quick look. I see 4 really tall ones. And then down in the corners, I see 2 really short ones that are a little hard to see from this video. To make this a little clearer, I've gone ahead and separated out our individual petals. You can see our 4 petals here. You can see we have a full complement of our 6 stamens. Here's our ovary here, clearly separated with its receptacle. And here's our 1, 2, 3, 4 sepals. So now we're ready to open our book and start keying. Again, we can start in our artificial key to the families, but we get to jump all the way. We know that many of these, we've been through this key enough times now that we know that we're looking at terrestrial plants that produce seeds that are not on a woody surface like a cone. We know that we have ovules enclosed in an ovary. Our flowers are not matching this 4A couplet. They're not branch parasites. And in fact, we can go all the way down to our group 6 on page 20. We also know from our investigation a few other things. We had the opportunity to see if we had a gamelped or a polypet corolla. We know we have an actinomorphic polypetalous corolla, so that'll help us when we get to page 20. Right away we can see that our leaves are not modified to function as traps for insects. You may not recall our plant. Whoa. Here are our leaves. No, those are not insect traps. They're just normal leaves. The flowers are not tightly clustered in heads or thick conical ovoid spikes. So we can go to 5B. This one says 9A wants our leaves to be all opposite and scale-like and connate, forming a low rim around the stem without a blade. We know we can't do that. So we're going to have to go with 9B, which gives us many other options. Are our plants parasitic or mycoheterotrophic and without visible green color? No, we had a very green plant. Is the juice of the stems milky? Turns out, no. We do not have milky stems. And we can test that here. Juice of stems is clear, not milky. Other characters not as above. Leaves whorled 3 or more per node. That doesn't match us. Leaves alternate, opposite, or all basal. Remember, we had opposite leaves at the base and alternate leaves at the top. Corolla polypet or corolla polypet and strongly bilaterally symmetric or bilabiate. That means the flowers are zygomorphic or like a face, or corolla polypetalous but radially symmetric or gamelped. They can sometimes be gamelped in that group, gamelpetalous in that group. Generally otherwise. Here's our flower again, a little blurry version here, but this is a clearly very actinomorphic flower. Here we go. With 4 very clear, showy petals. In this particular case, though in this family, they won't always be like that. 15A, we get to choose between the perianth 2 or 4 mirus, apetalous or polypetalous, or we can go with 15B, perianth generally 5 mirus. Occasionally 3, 6, or 7 mirus, parts numerous or lacking. Or if 2 to 4 mirus, then gamopetalous, stamens various. Well, we know that in our individual, we certainly have a situation where we have a 4 mirus plant. We saw that very clearly. The stamens were 6, and the other perianth parts were generally 4. There are 6 stamens, 4 petals, 4 sepals. That puts us at subgroup 6D, a very clear choice for 15A, subgroup 6D. Here we are in subgroup 6D in the artificial key of Flora of the Pacific Northwest. Our first question here is, are the flowers minute and embedded on the surface of a stout, fleshy spike enclosed by a large bract? Well, 1A will look familiar to some of you, especially those of you who've been out looking at skunk cabbage, but clearly that is not the case with our plant. So 1A is ruled out. 1B, flowers showy or minute, not embedded in a fleshy spike, not enclosed in a spathe. 2A, ovary partially to wholly inferior or superior, but invested by a free hypanthium. Okay, so let's talk about superior and inferior ovaries with this plant as an example. Whoa, excuse my book, it's a little floppy today. Okay, hold on to your hats, the movement is coming. Here are our flower parts that we dissected early on. Let's zoom in on that ovary. If you'll remember, all our flower parts came off of that green receptacle below the stipe, and the ovary is above that. So I've laid this the female parts here on their sides, but you can see the ovary is clearly above the other parts. Whoa. Here we go back to our book. We'll refocus. So partially to wholly inferior, enclosed in a free hypanthium, does not work for us. And you'll see that Rosaceae is the first family that keys out under that group, because of course we know that they have that partially inferior ovary that's frequently in a hypanthium. We can go to 2B. Under 2B, we get to choose pistils 2 to numerous, fruits, follicles, or achenes. We get to rule that out right away because, as we were just looking at, our ovary is singular. Our pistil is singular. We just had one pistil to look at. And if you need a reminder of that, flip back to where we just were looking at the flower parts. 9B, pistil 1, fruits diverse. We like that option. 11A, leaves opposite or opposite below and alternate in the inflorescence, blades simple. We do like that 11A. Let's see what 11B says. (11B) says leaves alternate or all basal, leaf blades simple to variously lobed or compound. So no key is perfect, and especially as we have introduced species, sometimes we can have misleading couplets. And in this case, I feel like this is a very misleading couplet. If we take 11A, leaves opposite or opposite below, and alternate in the inflorescence, that sounds right. That's what we observed with our plant right at the very beginning. Here are the opposite leaves at the lower end of this plant, and then here they are becoming alternate.